Hello, welcome to video 2C. This video is called Showing Congruence. I'm Mr. Miller, and you must be a geometry student. Let's get started. Okay, well, here's the main idea, what this is all about. Two figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. That is, by reflections, translations, or rotations. That's our idea of congruence. That's a pretty important idea. So like here in the figure, we have two parallelograms, kind of a pink one and a blue one. If I want to show that the pink one is congruent to the blue one, I have to be able to provide a transformation that would map it on top of it. And it looks like we could do it. In fact, in this case, it's just a translation. So if two figures are congruent, we should be able to describe the transformations that would map one onto the other. Usually, we do that by writing a rule. Okay, for instance, in this case, we got to check out two matching points here. We're going to go left, 1, 2, 3, 4, and it looks like we're going to go up 4. So we would write a rule for this. We'd say, here's the transformation. Any point x, y is transformed to this point, x minus 4, and actually y went up, so y plus 4. Went 4 to the left, that's the x minus 4. Went up 4, that's the plus 4. And that transformation would put the pink parallelogram exactly on top of the blue one. Okay, so this video is about getting a little practice and seeing how to do this, how to map one figure on top of another. All right, so we're going to do three examples here. Okay, so we want to show the following figures are congruent, and we're going to write a rule that maps the black arrow here onto the red arrow. Okay, and down here to the right, for a reference, I have the rules for rotations and reflections to help us out. Now, this is going to take more than one step. This actually can be done in 2 steps. Usually, I start by seeing if the figure is pointed the right way. We see that the black figure needs to be kind of flipped and point towards the right. So I'm going to do that, I'm going to reflect it, and then I'll move it in the right spot. So I'm going to start by reflecting over the x-axis. Actually, I'm sorry, the y-axis. So reflect over the y-axis. Okay, and then I'm going to see if, I like it, if I can work with it. If not, maybe I have to try something else. So this point right here, I didn't label them, so it's going to go there. And this point's 4 to the left. It's going to go 4 to the right. So it's going to go there. That point was there. And this point's going to go 4 to the right. Or left, rather. So I'm having one of those days here. And then this point is 3 to the left. It's going to go 3 to the right. It'll be about right there. And you know how it goes, really kind of hard to draw with the digital pen. But, that's terrible. But I can at least see that now it would be pointing the right way if we did that. So I had the computer draw that, so we can work with that. So this is what I was trying to draw with my digital pen here. And that's the reflection over the y-axis. Now that it's pointing the right way, we can kind of transform it. Just translate it so it's down here. Okay, well, let's write the rule for all of this. Okay, so it starts with x, y. We reflect it over the y-axis, so to do that, that would be minus x comma y. And then we need to translate. So we got to figure out how much x changed and how much y changed. Here, we're going from here to here. So x goes up by 1, 2, 3, 4, 5, 6, 7. It goes from -4 to 3. So I need to move it right 7, and that's x plus 7. And then we need to move it down. So 7 to the right would be here. We need to move it 1, 2, 3, 4, 5, 6 down. And that would do it. So there's our reflection over y-axis, and here's our translation. And it was along the vector 7, negative 6. So see the relationship between the vector and the rule? The vector tells me what we add or subtract to x and y. Alright, let's take a look at this one. So again, we're going from the black figure to the red one. And I see that somehow I need to flip this over. If I just reflect it over the x-axis, that would flip it over, but this long side would be on the left. And I really want it to be on the right. So this time I need to rotate, and we need to rotate it by 180 degrees. Okay, and the rule for that is xy goes to minus x minus y. Just take the opposite of the coordinates. So this point is at 1, 1. It would be at negative 1, negative 1. This point is at 3, 3. It would be at negative 3, negative 3. This point is at 4, 3. It's going to be at negative 4, negative 3. And where am I at? This point right here is at 5, 1. It's going to be at negative 5, negative 1. So, actually this point was right there. So if I draw it after rotation, it's going to look something like that. And as messy as this is, I see that is pointed the right direction. Okay, so time to switch to the computer drawn one. That's what I'm trying to do here. Alright, so that's the rotated one by 180 degrees, and we see that we just need to now move it up. We need to move it up 1, 2, 3, 4, 5. Okay, so let's write the rule to do all this. So we have xy. The 180 degree rotation was minus x minus y. And then the translation. Well, we're not changing x at all because we're not going to the left or right. We're going straight up 5. So it's just going to be y plus 5. We did it. We wrote the rule for the sequence of transformations. Now, the rotation, the translation, they're isometries, they're rigid motion, so they don't change the size or shape. So we know that when we rotated it to get the green trapezoid and then translated it, we maintain congruence. The black one is congruent to the green one, and that's congruent to the red one. All right, time for our last example. So this one, we kind of have this weird shape here. And we're going to start with the black one and transform it to the red one. So I see I need to turn it somehow. If I rotate it 180 degrees, it would be kind of pointing to the right. That's not quite right. And if I reflect it either to the right or below, it's still not going to be right. I need to rotate it. And we need to rotate it 90 degrees counterclockwise. So we have xy gets mapped to negative y x. Okay, so here we go. This point is 1, 2. It's going to go to, well, let's see here. Sometimes with rotations, I like to write it out. Negative 2, 1. So negative 2, 1 is right here. This point right here is at negative 1, 4. And it's going to go minus y, x. Negative 4, negative 1, which is right here. Actually, I kind of see how this is going to go. This side right here is going to go down. So it's going to go down 4. So sometimes we can start figuring out what it's going to look like. This side is going to go down 2. And it's going to look like this. So here we go. That's that. This goes here, there, 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 and there. Looks exactly right, huh? Anyway, at least I find that it's pointed the right way. Then we're going to translate it to go here. So you know my trick. I have a computer drawing ready. There we go. The green one is what we get when we rotate it by 90 degrees. So now we'll figure out the translation. Okay, so here goes the rule. xy. The 90 degree rotation we already had was minus y x. That's here in the table, the first row. Then we got to put how much we need to translate it. So we rotated to go from the black to the green. Now we're translating to go from the green to the red. So I'm going to pick these two matching corners to see how I move the whole figure. So it doesn't have to move up or down, so we're not changing Y. And it looks like we're moving 1, 2, 3, 4, 5 to the right. So this would be x plus 5, comma, y. There's our sequence of transformations. The fact that I could find one that maps the black one on top of the red one shows that they're congruent. Okay, we made it. Time for the journal assignment. So you got 3 things to do here. I want you to describe in words how triangle ABC can be mapped onto triangle DEF. Okay, so somehow you got to turn this upside down. So you decide. So describe in words, and you can do it in 2 steps. So describe both steps. The second thing is to write an algebraic rule, like we did for each of the examples, for the transformations you described in step 1. And third, I just want you to think about, once you have that done, could you have switched the steps and it would have ended up being the same thing? Did it matter this time, the order of the steps? All right. I look forward to seeing it in your journal. Take care.